All right, so our goal today, we're going to be doing our 2.2 notes, which is biconditionals and definitions. So we're going to move on to our notes, and then you guys will have plenty of time to keep working on 2.1 assignment and the 2.2 assignment. You should get them both checked in before you leave today. So today we're discussing biconditionals and definitions. So our goal today is going to be to learn to write biconditionals and recognize good definitions. Now, yesterday and the 2.1 assignment you guys were working on today, we've been talking about conditional statements, which are the if-then statements, and their converses. So if you take the hypothesis and flip it, and you still have that if-then statement, it's just read backwards. A biconditional is a scenario where both the conditional statement and its converse are both true. So then if they're both true, you can move on to writing a biconditional statement. So this is a statement where both the conditional and converse and its converse are true. So, I'm going to write a conditional statement, and we'll have to figure out if it's true or false. And if it's true, I'm going to move on. I'm going to write its converse. We'll have to figure out if that's true or false. And if both of them are true, then we'll get to see how we're going to write a biconditional. Okay? So the conditional statement that we're going to work with is if two angles have equal measures, then the angles are congruent. If two angles have equal measures, so the angle measures are equal, then the angles are congruent. Is that always going to be true? Yeah, that's the definition of congruent, right? Is that the angles have to have the same measure. So if two angles have equal measures, then they are congruent. That is going to be true. So I'm going to mark this as true over here. I'm just going to put a T there so I know, yep, my conditional statement's true. And then what I need to do is I'm going to look for my hypothesis and I'm going to look for my conclusion so I can switch the two and read this backwards for the converse. So if two angles have equal measures was my hypothesis, okay? Then they are congruent is my conclusion part. So now I'm going to write it by switching the two because that's what a converse is. I'm still going to put my subject at the beginning, if two angles. And this time I'm going to write are congruent. Then the angles, or they, it doesn't matter, have equal measures. So the equal measures part got exchanged with being congruent. If two angles are congruent, do they have equal measures? Is that always going to follow? Yeah. So this one's also true. Since they are both true, we move on and we can write the biconditional statement. Okay? Now, a biconditional statement is written a little bit different. It's no longer an if-then statement. This biconditional is an if and only if statement. And the if and only if part of it comes in between the hypothesis, if and only if, conclusion. That's how it's going to be read. Hypothesis, if and only if, conclusion. Okay? So we're not going to start with if. We're going to start by talking about two angles are congruent. That's how you're going to start this one. So two angles, and it doesn't matter. You can start it, you can write it in the order from the conditional statement or the converse, because what a biconditional statement says is that you can read it forward or backward, and it's going to remain true. Okay? So two angles have equal measures. If and only if they are congruent. Two angles have equal measures if and only if they are congruent. So this is that key term right here in this sentence. A biconditional is an if and only if statement. Okay? And again, I used my conditional statement this time. So we said they have equal measures if and only if are congruent. So that's the way that we wrote it. It doesn't matter. You could have written two angles are congruent if and only if they have equal measures, because again, the if and only if tells you that you can write it forward or backwards. It's kind of like, what are those words called? Do you guys remember? Like race car can be read forward and backwards. Isn't it a palindrome? Palindrome? Yeah. Right, is that what it's called? Palindrome. So it's kind of like that, where it can be read forward or backwards. Don't switch all your letters around because that'll just get confusing. But okay, so the next thing I want to bring up is we do have an abbreviation here. Okay? But that phrase, if and only if, is very important. So if you choose to use the abbreviation on any paper you use it on, you have to somewhere tell me if and only if, oops, I'm getting ahead of myself, if and only if is equal to IFF, because you can abbreviate if and only if by calling it IFF. Okay? So this has to be on your paper if you want to use that IFF as an abbreviation. Okay, so you must put it on any assignment, quiz, or test if you use IFF. Okay. The symbolic representation just says if you have your hypothesis, it leads to your conclusion. And then you flip those, your hypothesis and conclusion for the converse. So you'd have Q goes to P. If you have your conclusion, it leads to your hypothesis. And if both of those are true, then the way that you can write this is P, an arrow with both ends, because it could go in either direction, and Q. So you can go P to Q or you can go Q to P. The biconditional tells you you can go both directions. So if we were reading this in a sentence, this would say, if P, then Q. This one would say, if Q, then P. And then this one would say, P, if and only if, Q. And remember, that means if and only if. So, if you write a good definition, you should be able to write it as a conditional statement. Okay? Then you should be able to write its converse, and both of them should remain true. And if they do, that means it's a good definition. And that means you can go on to writing a biconditional statement. Okay? Because when I describe something, I want to know that you can identify that vocab word. If I'm describing something and you can come up with like 15 things that I'm describing, then I didn't define that thing well enough. Does that make sense? So if I said, a shape with round edges, what are you going to tell me it is? It could be a circle. What else could it be? An oval. It doesn't even have to be either of those. It might be a squiggly looking shape or look like a kidney bean. So that would not be a very good definition because you're able to come up with circle, oval, kidney bean, weird squiggly thing. Okay? So that wouldn't be a good definition. But if I said a quadrilateral with 4 equal sides and 4 right angles, what shape are you thinking of? What is it? A square. And that's the only thing that you can say. Right? So that would be a good definition if you can narrow it down to one thing when I describe the thing I'm talking about. So, the conditional statement we're going to do is, it says the definition for perpendicular lines are 2 lines that intersect to form right angles. So, if 2 lines are perpendicular, then, so if we're defining perpendicular, so 2 lines are perpendicular. Oops, sorry. Then, what's my conclusion going to be? Well, what's a better word than they cross? They intersect and form a right angle. Okay, so if 2 lines are perpendicular, then they intersect and form, or to form, right angles. Why? But you said if they are perpendicular. Perpendicular means that they have to form right angles. So you're saying if 2 lines are perpendicular, then they intersect to form right angles. That's a true statement. That's the definition of perpendicular. They have to intersect and they have to form right angles. So if they're perpendicular, then that definition must follow. So yes, this is true. Okay. How would I write the converse to this statement? If, who wants to give it a try? Yes, we have to keep the 2 lines at the beginning. If 2 lines, that's something that's usually forgotten. But remember, that subject has to stay at the beginning. We have to introduce it at the beginning. We don't say, if it blah, 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 then 2 lines. We introduce the subject at the beginning. So if 2 lines, keep going. If 2 lines intersect to form right angles, then they are perpendicular. Very good. If 2 lines intersect to form right angles, then they are perpendicular. So if you have 2 lines and they intersect and they form right angles, are they always going to be perpendicular then? Yeah. So that's also true. Since both of those are true, we can go on to writing the biconditional. How would I write this biconditional? What are we thinking? Who wants to give it a shot? Who's saying it? Go ahead.
Okay, two lines are perpendicular if and only if they are right angles.
Very, very close. You have the two lines are perpendicular if and only if, I'm going to use the abbreviation here, if and only if. And what was the conclusion?
They are right angles.
They have to intersect and form right angles. So yes, okay, if and only if they intersect to form right. Yes. Yep. So if you were to say two lines intersect to form right angles if and only if they are perpendicular. Is that what you're saying? Yep. And that doesn't matter because the if and only ifs tells you can read it hypothesis conclusion or conclusion hypothesis because either way is correct because that's how it is. Those are your notes for today. The 2.2 assignment is the page behind that. But you guys have the rest of the time today to work on the 2.1 assignment, get it checked in, and the 2.2 assignment and get that checked in.